we are going to study chemical reactions of haloalkanes and haloarenes. Friends, as we have seen in the previous lecture about SN1 and SN2 reaction. So, generally, primary alkyl halides are giving SN2 and E2 reactions. Secondary alkyl halides will give SN2, E2, SN1 or even reaction as per the condition. Tertiary alkyl halides will give E2, SN1 or even reaction as per the condition. What are these conditions which is mentioned in the bracket? E2 means elimination biomolecular. When there is a bulky base present in primary alkyl halides, then it will go for E2 mechanism. When in secondary alkyl halides, strong base as a nucleophile is present, then it will go for E2. But if the base is weak or nucleophile is weak, then it will go for SN1 or even reaction. In tertiary alkyl halides, if strong base is present, then definitely it will go for E2 reaction. And if the base is weak, then it will go for SN1 or even reaction as per the condition of substitution or elimination. Now, let us see few reactions. The first reaction is known as Wurtz reaction. Here we have taken two different iodide. One is iodomethane and second one is iodoethane. In presence of 2 moles of sodium metal, we will get propane as a product. Means here we are preparing alkane from alkyl halide. So this is known as Wurtz reaction. This reaction is used in dry ether as a solvent. Second reaction is very well known, Friedel-Crafts Alkylation, in which benzene is treated with bromomethane and we will get toluene as a product. So this is known as Friedel-Crafts Alkylation. Third reaction is beta elimination, or beta elimination means dehydrohalogenation. Here we have taken bromoethane. So bromine and hydrogen will removed. In presence of alcoholic KOH, we will get ethene. But if we are having 2-bromobutane, then we may have two products as per the Sadzev rule. First product, which is more 80%, that is but2-ene, and another product is but1-ene. So here we have to follow Sadzev rule. The next reaction is with silver nitrite. So when bromoethane is reacted with silver nitrite, we will get C2H5NO2 as a major product, while C2H5ONO is a minor product. Why it is so? Because silver is connected with oxygen and forming d-pi-p-pi bond. So due to this d-pi-p-pi bond, nitrogen directly not attached with carbon, right? So we are getting nitroethane much more. If we use KNO2 instead of AgNO2, then we will have major product as ONO. So we have to remember this. AgNO2 will give nitro compound. Next, if we use aqueous KOH or moist Ag2O, as we have already done in SN1 reaction, that is simple substitution reaction. So when we are using aqueous KOH, we are going to use SN reaction, means substitution reaction. So bromoethane will give ethanol. If we use Ag2O dry and if we take 2 moles of C2H5Br, we will get diethyl ether, means ether preparation is there. So we will get ethoxyethane or diethyl ether in presence of Ag2O. Now third is very well known, Williamson ether synthesis, in which we are going to use bromoethane and sodium methoxide. This is CH3ONa is known as sodium methoxide. So Br and Na will be byproduct and we will get methoxyethane. This reaction is known as Williamson's ether synthesis. Next, if we add KNH2 in bromoethane, we will get aminoethane. So this is amine formation. If we use KCN in C2H5Cl, chloroethane, we will get C2H5CN. Its common name is ethyl cyanide or propane nitrile. Now again here KCN is ionic. Instead of KCN, if we use AgCN, then we will get C2H5NC, that is isonitrile or isocyanide. Why? Because again silver cyanide will have d pi p pi bond, so we will get isonitrile product. So if you want to get cyanide, we will take KCN, right? Now very important part is these nitrile compounds are very much useful to prepare carboxylic acid and amine. So here I have just mentioned one very important reaction which will be helpful in further chapters. Like if you take ethyl cyanide or propyl nitrile, then by strong hydrolysis we will get propanoic acid, and if we do reduction of this nitrile we will get aminopropane. So that is formation of amine, means reduction of nitrile will give amine and hydrolysis will give carboxylic acid. So this is a glimpse of the all reactions. Again you can see here this is a mind map RCH2CH2X. So if we use ROK, then we will get ether. Yeah, we can also prepare Grignard reagent in presence of ether. If we use magnesium, then we will get RCH2CH2MgX, which is known as Grignard reagent. If we use another RX, then we will get alkane in presence of sodium, that we already done as a Wurtz reaction. If we do reduction, direct reduction, then we will get alkane, and if reverse reaction, if we add halogen in presence of sunlight, we will get alkane. As we have seen, if we add KNO2, we will get RCH2CH2ONO, and if we add AgNO2, we will get RCH2CH2NO2. AgCN, as I mentioned, we will get isonitrile. KCN, we will get nitrile. If we add alcoholic KOH, we will get alkene, and if we add KSH, we will get thiols, and by adding KNH2, we will get amines. This is the same thing but another snapshot. So here there is an alkyl halide. You can get ether, thiols, sulfides, nitriles, halides, ester also, as well as extended alkynes. So for extended alkynes we need to add an ionic alkyne in it, and we can also get azide. These two reactions will come in competitive exam. Another reaction map, so that you just see and just check, like I have just given the numbers. So 1 2 number is for the preparation, 3 4 is the preparation of alkene from halide, 5 6 from halide to alcohol, 7 8 to prepare ether, 9 number to prepare thiol, 10 number to prepare thioether, 11 number to prepare ester, 12 number to prepare azide, 13 number to prepare nitrile, and 14 number to prepare alkynes. It is also known as extended alkynes. So you can give this number and then check the answer from the next slide. So that is your homework. Here you can see that reaction number is given, what type of reaction is that is given, which are the conditions, that is also given, and it is preferably for what, primary, secondary or tertiary, what type of halide, that is also given, and it is SN2, SN1, E1 or E2, everything is mentioned. Maximum reaction of this part is substitution. Now this is another mind map, so it is all repetition to just view it again and again. So here again halides is preparing alcohol, then alkene, then ester, then carboxylic acid from cyanide, right? Amine from cyanide again. So this is very very important to prepare cyanide from halide, halide to cyanide, then cyanide to acid, and cyanide to amine, right? And again here we can get the product halide from the alkene. Now let us see few reaction of aryl halides, or we can say other halides. So in aromatic halo compounds, substitution reaction is not easy. Why? What is the reason for that? So the reason is that halogen is having 3 lone pairs. So due to resonance structure, the lone pair is not easily available, and due to that the substitution is not easily possible. Same way in vinyl halide, vinyl chloride, you can see here, because of resonance they are not giving substitution reaction very easily. So this type of question will come, okay, why aromatic halides as well as vinyl halides are not giving substitution reaction easily. So the reason is what? Their resonance. So here, due to resonance, carbon and chlorine bond is partially double bond. So to break the double bond we need extra energy. Substitution reaction is only done by sigma bond, while here a partial double bond will require more energy. That's why substitution reaction is not so easy. So let us see few reactions. So the first reaction is known as Douse process, which we will also study in next chapter of phenol. So we are preparing chlorobenzene to phenol in presence of aqueous NaOH with 300 degrees Celsius with high pressure, right? So Cl is exchanged by OH, but we are having a strong conditions. So again, it is not so easy. From chlorobenzene, we will get aniline by adding ammonia and Cu2O as a catalyst. Again 200 degrees Celsius and under pressure we will get aniline. If we add CuCN, pyridine, with high pressure, high temperature, we will get benzonitrile from the chlorobenzene. Suppose we are having 2,4,6 trinitrochlorobenzene, it is known as picryl chloride, then that reaction is easy. Means here we can understand that NO2 group is enhancing the substitution reaction capacity of aromatic halides. So if we are having 3 nitro group, you can see here there is no conditions over here. So we are directly getting picric acid. So here I have mentioned relative order of reactivity of chlorobenzene having electron withdrawing group in ortho and para position. So you can see that 2,4,6 trinitrochlorobenzene, which is known as picryl chloride, is having more reactivity than 2,4-dinitrochlorobenzene, then para-nitrochlorobenzene, then we are having just chlorobenzene and vinyl chloride. So this is the reactivity series. There are further reactions. So first reaction is Wurtz-fitting reaction. So to prepare toluene, this is another reaction. If we use bromobenzene and methyl bromide, means one is aryl halide, one is alkyl halide, we will get alkyl benzene, right? So this is toluene. It is known as Wurtz-fitting reaction. Only fitting reaction in which we will take 2 moles of bromobenzene and sodium metal in dry ether, we will get diphenyl as a product. That is one competitive reaction, that is Ullmann reaction, in which we will take iodobenzene 2 moles in presence of copper metal. Just with heat we will again get diphenyl. Aromatic halide can also form Grignard reagent. So just we take bromobenzene, magnesium in dry ether, we will get phenyl magnesium bromide. There are few side chain reactions are also there. Like we are having orthochlorobenzyl chloride, we can prepare from chlorotoluene. So from toluene we get benzyl chloride. So here it is chloro substituted toluene. So we will get again chlorination on methyl group. And if we see the reaction with KMnO4, so toluene, like only toluene is giving benzoic acid. So this is chlorotoluene, we will get chlorobenzoic acid. So these are a few side chain reactions. Now there are few more di or tri-halogenated compounds. So let us first see chloroform or trichloromethane. So we can prepare trichloromethane from methane. So for that we require 3 moles of chlorine in sunlight. We can also prepare this from tetrachloromethane in presence of ion fillings in water. So we'll get chloroform. Now as well as we can get chloroform from ethanol or ethanol, or we can get from ethanol and ketones. So by distillation of ethyl alcohol with a paste of bleaching powder in a water, which is well known as bleaching powder, we can get a chlorine, which is very strong oxidizing agent. So how it is preparing chloroform? Let us see in the next slide. So ethanol with chlorine, it will do oxidation of ethanol and we will get acetaldehyde. Acetaldehyde again with chlorine will give chloral. What is chloral? CCl3CHO. It is trichloroethanol. What is chloral? Trichloroethanol. So this trichloroethanol is reacting with COH twice, which is present in the solution. So it is reacting with calcium hydroxide and will form chloroform and calcium formate. So this is the preparation from ethanol. Now acetone, if we use acetone again in presence of chlorine, it is forming trichloroacetone. This trichloroacetone is reacting with calcium hydroxide. We will get again chloroform and calcium acetate. So yield is higher in case of acetone, right? Because it is directly giving the product. So this is chloroform formation. Now this chloroform is used in distinguished taste of primary amines. So when chloroform is reacted with primary amines, whether it is aromatic or aliphatic, in presence of alcoholic potash, or we can say potassium hydroxide, we will get C2H5NC, it is known as ethyl isocyanide or carbylamine. So it is having a specific order, right? Due to that we can easily identify. So instead of primary amine, if we take aniline, then again also we will get phenyl isocyanide. So this is known as carbylamine taste. Only NH2, primary amine means NH2 group is having 2 hydrogen. So this 2 hydrogen as well as 1 hydrogen from chloroform, 3 hydrogen with 3 OH will form 3 water. So without 3 hydrogen this reaction is not possible. So this reaction is only given by primary amines. So remember that. Very important one is iodoform. Iodoform also can be prepared from 3 things. Just remember. Number 1, 2-ol, propane 2-ol, butane 2-ol, any 2-ol. Then any 2-on means propane 2-on, butane 2-on, right? And then it's 2 exceptional case, ethanol and ethanol. So just remember, iodoform taste is a specific taste for COCH3 group. In COCH3 we can take ethanol, ethanol, 2-ol and 2-on. This type of molecule will give iodoform taste. Now what is this taste? So we are adding iodine in presence of NaOH. So we will get iodoform. This iodoform is yellowish in color, or sometimes it is giving yellow precipitate. So this is one type of oxidation process, right? On heating we will get a yellow PPT, while chloroform is not giving this type of PPT. So this is specific taste for 2-ol, 2-on, ethanol and ethanol. So this is another taste. This iodoform decomposes to free iodine when it comes in contact with organic matter, and hence it is used as an antiseptic. So it is also having characteristics order and having a crystalline precipitate. So from this we have to just remember, we can prepare ester, nitrile, alcohol, amine, alkene, extended alkyne, ether, nitro, halide, alkane, isonitrile or carbylamine, Grignard reagent, chloroform and iodoform from these halides. In these halides we also seen few name reactions, Wurtz name reaction, Williamson ether synthesis, fitting, Wurtz-fitting, Ullmann, Grignard. You can also add Friedel-Crafts. And we understood 3 important distinguished tests: iodoform, carbylamine, iodoform for 2-ol, 2-on, ethanol, ethanol, carbylamine for primary amine. Lucas, we have just seen the preparation in halides. So ZnCl2 NHX will identify primary, secondary and tertiary alcohol. That we will learn in next chapter also. So friends, this is just conversion map. Just every day see this map, and after finishing all your chapters of organic chemistry you just go through it, so you will get lot many idea for getting conversions from one molecule to another molecule. So again, Please follow Gandhian philosophy. So this is eco-friendly alphabet for you. And follow 9 R's. Thank you so much.